The James Webb Space Telescope has quickly become the most advanced observatory of its kind, offering scientists an unprecedented tool to study both our solar system and the far reaches of the cosmos. Its mission spans a wide range of objectives, from probing the mysteries of planets orbiting distant stars to examining the larger structure of the universe itself, and even our place within it. Recently, astronomers used this extraordinary telescope to focus on a star located about 120 light-years away. What they discovered has stirred intense interest in the scientific community. Signs of carbon-based molecules in the atmosphere of what may be an ocean-covered exoplanet. This detection is particularly significant because it provides a window into a planet that seems vastly different from any found in our own solar system. The planet in question, K2-18b, is drawing attention due to its potential to support life. Webb's instruments have detected molecules like methane and carbon dioxide in its atmosphere, substances strongly associated with biological activity on Earth. These observations build on earlier research, including data collected by the Hubble Space Telescope, which had already suggested that K2-18b might possess a hydrogen-rich atmosphere and a surface covered in water. K2-18b is located in the constellation Leo, orbiting a cool dwarf star known as K2-18. Importantly, this planet resides within the so-called habitable zone, an orbital region where conditions could allow liquid water to exist. Planets like K2-18b, which are sized between Earth and Neptune, are relatively rare in our own solar system, making this type of discovery even more intriguing. The presence of carbon compounds in its atmosphere, combined with its size and location, opens up compelling possibilities for the study of habitable environments beyond Earth. Another particularly interesting aspect of K2-18b is the potential detection of dimethyl sulfide, a compound known on Earth to be produced only by biological processes, specifically by marine phytoplankton. However, scientists caution that the current evidence for dimethyl sulfide on K2-18b is tentative and will require further confirmation. Additional observations from the global network of telescopes are planned to verify this potential biosignature. Despite these tantalizing clues, scientists emphasize that the discovery of carbon-bearing molecules does not necessarily mean that life exists on this planet. One researcher from the University of Cambridge explained that although K2-18b lies within the habitable zone and shows promising chemical signatures, its radius, about 2.6 times that of Earth, suggests a core enveloped by a thick, high-pressure mantle of ice, similar to Neptune. This would be overlaid by a thinner, hydrogen-rich atmosphere. While oceans of liquid water might exist on this planet, it remains uncertain whether they possess the right conditions to support life. Nonetheless, scientists have managed to obtain the most detailed spectrum yet of a sub-Neptune planet in a potentially habitable zone. This data has allowed them to identify various atmospheric molecules with impressive precision. One member of the Cardiff University team explained how this was achieved by studying the light from K2-18b's host star as it filtered through the planet's atmosphere during transit. Because K2-18b is a transiting exoplanet, it periodically passes in front of its star, causing a brief dip in the star's brightness. This phenomenon allows telescopes like Webb to capture subtle changes in starlight as it moves through the planet's atmosphere, leaving spectral fingerprints that reveal the gases present. The research team now plans to use Webb's mid-infrared spectrograph to gather additional data, which will help confirm the findings and provide deeper insight into the planet's climate. Ultimately, the overarching goal is to search for signs of life on exoplanets in habitable zones, an achievement that could fundamentally change our understanding of the universe. Beyond K2-18b, the James Webb Space Telescope has also made another remarkable discovery: complex organic molecules in a galaxy located billions of light-years away. These compounds, which resemble substances found in smoke or smog on Earth, are the most ancient of their kind ever detected. Technically known as aromatic hydrocarbons, they are made of long chains of carbon atoms and are typically found in materials such as petroleum, coal, or polluted air. What's surprising is not just their presence, but their complexity. These molecules are far more intricate than simpler compounds like water or carbon dioxide. What makes this so astonishing is the age of the galaxy where these molecules were found. It formed when the universe was only about 10% of its current age, just 1.5 billion years after the Big Bang. Given that the universe is now about 13.8 billion years old, detecting such complex chemistry so early challenges existing models of cosmic evolution. It implies that the universe was capable of generating sophisticated organic material much sooner than previously thought. This discovery was made possible by Webb's ability to observe light from incredibly distant galaxies with extraordinary clarity. The molecules were identified in a galaxy named SPT 041847, which is already as massive as our own Milky Way, despite its youth. Even more impressively, the stars within it have produced as much carbon and oxygen as those in our own galaxy, demonstrating that star formation and chemical enrichment happened very rapidly. What remains a mystery is why these complex molecules are distributed unevenly across the galaxy. That inconsistency is not yet understood, but it offers new avenues for research into how galaxies evolve and how organic chemistry spreads across the cosmos. The detection of these molecules in such an early epoch opens up the possibility of finding more of them even closer to the origins of the universe, potentially rewriting what we know about the timing and processes that shaped the cosmos. With every new revelation, the James Webb Space Telescope brings us closer to understanding the deepest mysteries of space. Whether it's identifying biosignatures on distant exoplanets or unraveling the chemical history of the early universe, this extraordinary tool continues to expand the boundaries of human knowledge and curiosity.